Now starting. All attendees are in listen-only mode.
Well, good morning, good afternoon, or good evening, depending upon where you are in this world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great event on tap. It's an interesting topic, but before we get started, I'd like to go over just a few housekeeping items. First of all, today's event is being recorded, so if you miss any or all of it, just know you'll be able to access it afterwards. We'll be sending out a link to the event that will enable you to access it on demand. And we are taking questions from the audience. So if at any time during the presentation you have a question for our panelists, please don't wait. Just use your GoToWebinar control panel, submit your question, and we'll take about 10 or 15 minutes near the end of the presentation and go through the audience questions. Okay, with that, we'll go ahead and get started with today's webinar, how to streamline testing in DevOps with behavior-driven development. Our speakers today are Mike Scott, who was Principal Consultant at Magenta, and Kevin Dunn, Senior Vice President of Global Channels at QA Symphony. Welcome, gentlemen. Thanks for joining me today.
Hey, thank you. It's great to be here. This is Kevin Dunn with QA Symphony. As mentioned, I'm the SVP of Global Channels, and we'll do a brief intro for Mike here before Mike gets started with the main content. So Mike Scott, we've done several webinars and events in the past and had a great relationship together. We've really enjoyed speaking with Mike on this topic of behavior-driven development. He's definitely an expert with over 30 years of experience in software development, IT in general, best practices around software development. So I'll give a brief background first on QA Symphony. So Mike, if you want to skip on to the next slide here. Just to give a little background, the reason for partnering with Magenta, which is the company that Mike is joining us from, is that Magenta is one of the leaders in sort of the process and implementation around BDD. Us at QA Symphony, we're really focused on providing tools that help testers to create better software, and especially do that in the context of Agile and DevOps. So we are a large company here in the US that's been growing quite rapidly and expanding around the globe to add offices in Europe as well as Asia. And we've just recently merged with Tricentis now to become a 600-person plus company that is providing solutions across test management, test automation, and load testing. So we're really excited about the BDD space in particular. Mike, if you can move on to the next slide. We provide a platform within the QTest brand, and two of the main products in that platform, namely QTest Scenario and QTest Pulse, are purpose-built for teams doing BDD. We also offer other pieces to the platform and modules that can be added on for teams that might be doing other approaches, not with sort of a test first or BDD process in mind. So we're really interested in the topic that Mike is going to be talking on today, which is streamlining testing in DevOps by using BDD. And he will be the one leading the conversation, as him and Magenta, as he'll explain in a minute, are really the experts in sort of the process change that needs to happen to enable success with BDD. So with that, Mike, would you like to give a brief intro on Magenta and dive into the presentation?
Certainly will. Thank you very much, Kevin. Yeah, so myself, my name's, as Kevin said, Mike Scott, Principal Consultant. As Kevin said, I've had over 30 years experience in IT now. Sometimes it feels like only yesterday, sometimes it feels like a lifetime. But in that time, I've seen quite a few changes and quite a few cycles. I'll talk about some of those in a moment. Currently, well, working for Magenta, and we're a company formed way back in 2004. However, the company really started to grow around about 5 years ago. Our principal aim is to help organizations develop better software. And one of the ways that we do that is through introducing behavioral change, organizational change, principally around engineering discipline. And one of the things we've found works really, really well is behavior-driven development. As I said, we've been around a good while, but the real change in the organisation happened probably around about 5 years ago. And from that point, we've had some quite phenomenal growth from the company. And very recently, in fact, just earlier this year, we joined up with NTT Data UK. So we are now part of a much larger organisation, but still like to retain the small company feel within that. There's a picture of some of the motley crew. We like to try and keep it a little bit light and a little bit humorous in the organisation, so everybody in the organisation, right up to the MD, has a Bitmoji. Okay, so what are we going to talk about today? So just because I recognise that we've probably got a fairly mixed organisation, fairly mix of people here. We've got some people who've probably just starting on the DevOps journey, probably some other people who are here with a fair, who are mature and want to find out more. BDD, I think probably everybody has heard of BDD, but I will go back and describe what I think BDD is all about. And I'll talk about a model for DevOps, how it's a model. I think there's, to my last recollection, there was at least a dozen different models for DevOps. I think there's also the definition of DevOps depends on which organisation you're working for and which suppliers you speak to. So I will talk around what I mean by when I say DevOps. I'll talk a little bit about how BDD works and how that fits in, and then I'll talk about, it's probably a fairly personal journey about how we've joined all of that lot together. I think one thing that's become totally apparent in my 30 years is the longer I get here, the longer I've been around, the more I'm uncertain as to what is best practice. And in fact, I think I've got to the point now where I don't believe in best practice. So, and I don't believe in the model for anything. So what you should see through here is I'll present a model for this, and I'll present some practices that have worked for me. I think a lot of this stuff is contextual, so what I do hope you take away from this today is not this is exactly how to do this, but I think my best hope is that you come away from this thinking, that's interesting, maybe there's one thing I can use from that. So on with the agenda. So what I want to talk about, start off basically talking about the models for DevOps and BDD. I will talk about the planning and aligning interests, how we create specification, and for a solution, and I'll define exactly what I think goes into that solution, and then how we focus in on that solution. So essentially, going on the right-hand side of the screen there, looking how do we go from problem through to solution from a business perspective and a technology perspective. So what are the problems that we have with delivering systems? Having been around a while, I've been through a lot of documentation. and there's a lot of stuff out there. There's a lot of stuff to read. There gets to be more stuff to read every single day. And as I like this graphic, this sort of fairly humorous graphic from This Is Index. The more stuff there is to read, the more stuff you're going to miss. So, what sorts of things do we have around here? We have business briefs, feasibility briefs, architecture documents, network designs, hardware specifications, program specifications, security designs. The list goes on and on and on. Couple of things just to point out that I think have changed fairly recently. Things like ROM Books. I don't know if anybody, people that who are coming from the operations side will know all about ROM Books. I don't know many people that really like them. They're a pain to write, they're a pain to follow. The reality often is different than the stuff that it says in the ROM book, but they're absolutely necessary, or used to be absolutely necessary in the old days, to just to make sure that when you build some infrastructure, it was built so the way that it was expected to be. There's also followed on with a whole bunch of checklists. So what I'm hoping to show is that we can, using behavior-driven development techniques and certainly some of the tooling, we can start moving away from that model of hard ROM books that are difficult to write, difficult to follow, and start automating that type of stuff. That's not principally the reason for doing it, but it does make things a lot easier. So let's go on to behavior-driven development. A lot of people, when they look at behavior-driven development, think, cucumber, gherkin syntax, given, when, then, or this. Interesting, speaking to the likes of Matt Wynn and Aslan Kellesley, that was the last thing that really they were thinking of when they started talking about behavior-driven development. The idea behind it was to start the conversation, and it was to clarify the conversations in development, to find a better way, an easier way of specifying the system, and then make sure that the system was actually developed to that, it was actually delivered to that specification. So the actual syntax, the mechanics of given, when, then, and mechanics of cucumber were almost a byproduct of the whole process. The good thing about those tools, though, is it does make you formalize stuff. Now, I don't know about you guys, but I've seen a lot of very woolly specifications in my time, particularly when you come to non-functional ones. The system must be performant. The system must be highly scalable. It's like, what does that mean? So one of the things that one of the things that behavior-driven development makes you do is makes you think a little bit more about what those specifications mean. And by having to formalize it slightly, it focuses the discussion a little bit more on the end product. So the cycle that we typically, one of the cycles that I've found works very, very well for BDD is exactly this cycle that's up on here. Again, not my work, but James Shaw, Brian Marrick, and Elizabeth Hendrickson really define this. But for me, it is BDD in a nutshell. We essentially take a story, we discuss it. From that, we pull out a specification. Now that will usually be written in, if you're using things like Cucumber, written as a series of feature files, but there are other ways of doing it. I'll talk about those in a moment, or a bit later, sorry. We then develop stuff to that specification and then demonstrate it, demonstrate that it meets that spec, demonstrate it back to the end user. And then generally what happens is there's a discussion on that. Yes, nearly what we want. Maybe we can do this, maybe we can do that, and we go around the cycle again. The interesting thing with things like Cucumber is that because we can formalize that specification, we can automate it. And if we follow test-driven cycle within BDD, we'll write down the specification. First of all, we'll run the automation, it will fail, and then we'll keep going until it passes. When it passes, we know that whatever we've developed meets that specification. Now that's all very well. That was all written basically, originally was written, the first version of Cucumber was written for Ruby. So it all works very, very well with application code. And to some extent, and this is coming for it, so please don't jump on me for this one, but the application code is not the most important part of the system, or not always the most important part of the system. You've also got to put some stuff for that to run on. You've got a whole load of other bits and pieces to join together, a whole bunch of stuff to configure. And sometimes, depending on what system we're writing, the application code is the easier part of the system. Particularly when you're using third-party products and your application code is just stuff which is things which glues those together, or a set of configurations. So we started thinking, how can you apply how can you apply that same technique to everything else? So let's look at where DevOps comes into it. So again, not my model. I think I stole this one from Puppet. I can't remember the exact source of it, so I should find that one out and quote it. But I guess most people may have seen this in terms of how DevOps works. We start off, we plan, we code, we build, we test, we release, we deploy, we operate, we monitor, then we plan and back around the loop again. Infinite number of times. Infinite number of times just to show the fact that once we've coded the system, hopefully it's going to be in operation for a lot longer than it took to actually develop. So I guess the question is, what is DevOps? I've seen various definitions from it, definitions about it. The one that I like, I think, is probably summed up in this little diagram. It is the whole lot. It's actually going from development through to operations seamlessly and delivering something for the business. Because I guess most organizations I've been in have been separated between the development part of it, and then the IT outfit or operations, everything gets thrown across the line. The other part of it, I guess, is that IT operations is often separated from business operations. Now, that was, I guess, I don't know when the real separation started with this. I guess the big rise of IT. The interesting thing I found was that I was actually I didn't know I was doing it, but we were doing DevOps 20 years ago. I was sitting in the finance office with a Sun Spark station under the desk of the chief accountant, and there's myself and another programmer, and we were sitting there trying to hack out a budgeting system for these guys. The company was British Telecom, so it's a fairly large organisation, or certainly was at the time. And we were basically building the budgeting system as they asked us to. So we sat there, we had an Oracle database on the box, we put some numbers in, they ran some reports. The reports either looked good or didn't look good. We went and we changed the code. We deployed it straight onto the server and we delivered it. Now, as a model for DevOps, that's sort of where we're trying to get back to, I think. Although we're trying to do it on a much bigger scale, obviously, with a lot more people involved. But the feedback cycle at those days was massive, and it took me a good 15 years to get back to that state, having gone through structured systems development, object-oriented programming, the agile movement, and systems engineering. And now we're finally seem to be coming back to the state where we can start thinking about holistically how can we get the business and IT working together so closely. So I like this model. I do think there's too many steps in it. I'm getting a little bit old, so my memory is not as good as it used to be. So I sort of simplify this down into 4 things. What we want to do is plan, build, release, and operate. The other bits, the other little steps that I've cut out, the plan, code, build, test, deploy, operate, monitor. So the ones that I've cut out are really the checking steps, the testing and checking steps. I haven't cut them out because I believe that it's perfectly possible, and what we should actually be doing is not have them as separate steps. They should be built in. So when we build something, everything we build, we should be building it, and in my view, we build it test first. So we write some tests, we write some checks to make sure we built it properly, and then we release it. Similarly, when we release stuff, we want to check that we're actually releasing stuff correctly, and I'll come on to that. When we're operating, we want to monitor what's happening. So that's part of the checking process. Is it actually performing as we expect? And we need to define specifications as to what are the normal bounds. So at that level, I don't see any difference between that between what we're doing. And so I believe that we can do all. I believe in the stuff that I'm doing more recently is all about how can we take a BDD type approach to making this work. So so what I've done in terms of bringing the things together is that all the way through every single one of these, every single part of those things, we go through that BDD cycle. We go through the discuss, the distill, the develop, we demo. So the planning stage, this is where we obviously software gets gets in the way here. But however, planning is just nothing more than discussing and distilling. We develop a plan and we demonstrate it to the customer. Building, again, that's the obvious part of it. BDD's parts of this process. We discuss, we distill the stuff, we develop the thing, and we demonstrate it. When we come to deploying, nowadays we're all about automated deployment, but I'm wondering how many people, I don't know how many people test their automated deployments, or how many people write specifications, how many people write unit tests for their automated deployments. How many people write integration tests and so on and so forth. And one of the things I'm trying to do nowadays is do more and more of that. When we come to operating, again, if there are other ways that we can specify what the normal operational parameters of the system, taking it the same approach, taking a BDD type approach to things. So that's one of the things that I'm interested in expanding. I have to say that that's probably the least. That's where my thinking is least mature, and I'd be very, very happy to have discussions with people about that one offline. So I always like to throw this card in. So I've waffled on for a good 15 minutes now without throwing in an example. To me, the easiest way to clarify what you mean is by throwing an example in, and certainly it works for us in behavior-driven development. So here comes the example. Sorry, hang on, the books are there. Yeah. Yeah, no, sorry. Where did they go? That's it, right, okay. Yeah. So let's look at the features. Sorry about this, my one of my slides got hidden. So just to go through, hopefully everybody hopefully everybody's at least seen something like this, but so I'll go through it very quickly. So in terms of what I mean by behavior-driven development, essentially we write out the specification in English. So as far as Cucumber is concerned, we have a feature file. We have which describes, in this case, the feature driver can pay by credit card. We put some business rules in there, so we put some text in there to explain how it works. And then the key thing here is that we describe how the behavior works in terms of scenarios. So we'll have a number of scenarios. Here we've got one, once paid, a driver a vehicle is on the payment list. And then this is when we get into the Gherkin syntax. So this is the formal part of the specification. Given we've got these vehicles, when we get a new call, and the driver pays, then we get the payment accepted, and so on and so forth. So let me just flip back to that one. So so that's an example of how we can do that for when we're discussing system behavior from a functional perspective. What I'll show you when I get into the detail part of it is how we can do that in a non-functional. We can do that for more non-functional things, and how we can do that for some of the more infrastructure type things. If you're really interested in deep diving on this, this is a good starting point for the reading here. The Cucumber book, always a good read. The thing that really got me thinking about how we bring this together was Gojko Adzic's book, Bridge the Communication Gap. And then for anything DevOps, then obviously the DevOps. Once you've read the Phoenix project, then go on to the DevOps handbook. Still a classic book. So let's delve into those 4 bits in a little bit more detail. The planning stage, or the planning part of the cycle or the continuum. I think the key, too many people when they start planning, start thinking a plan is all about putting a Gantt chart together or breaking things down into tasks and putting the points onto the stories and so on and so forth. To me, the key part of the plan is around the communication and getting everybody focused in the right direction. What you actually put into Jira or what you put on your card wall, what's written on the story cards, or whatever planning tool planning and tracking tool you use, is almost of secondary interest. The key part of it, to me, is the discussions and making sure that everybody has a very clear idea about what it is that you're attempting to do in the next iteration. So that's why I'm thinking about planning as aligning interests. When we start thinking about the planning, the things like specification by example start coming to this. So when you're looking at a story, thinking about how it's working, this is exactly where stuff comes in here. So we start thinking, can we start planning? Can we start thinking about what's an example? How's that going to work? If we don't have the appropriate examples, we can use things like example mapping to grab them. But once we've got this sort of stuff here, then that allows us to start thinking about the tests or the checks that we want to put in. How do we know when we're done? So, which all basically goes to elaborate, clarify, and verify the requirements. A really good technique, which I talked about in my previous webinar, is example mapping. If you haven't tried this, I definitely recommend doing it. It's a really, really fast way to get the clarity from the story of as a user, I want a web page so that I can see all of my friends and interests. I think this is the fastest way I've seen of actually clarifying all of those clarifying the requirements, and it gets you all of the stuff that you need for actually defining the scenarios. And it's a great way of breaking down stories, a great way of defining, of also pulling out all of those questions and getting those things to the side that you actually need to get clarified. So as a micro planning tool on the story, I think this is a brilliant example mapping is a brilliant tool, and it feeds exactly straight into your straight into BDD. Obviously, every one of your examples basically become your scenarios. So once we started planning things out, discussing how things work, we can start getting into the build for the system. This point, I'd definitely be reaching for tools like Cucumber. I'd be thinking about how do we refine the specification. And here again, we're looking at specification workshops. We're looking at how we go from how we refine those things down from those examples into how do those scenarios work, and then we start the process of automating directly. So again, using tools like Cucumber or other such tools. What we end up with at the end of this is a set of automated checks that we can start writing code to. In terms of how they should be, this is where we start getting sort of interesting in terms of how we lift this up from code to into infrastructure. The stuff we do, like self-documenting about intentions, there is one of the things that everybody says is that it must be based on business intentions and stuff. Yes, and it is about business intentions, but I deliberately took deliberately took the thing about business intentions out. That doesn't really fit for a technical level. Do the business really care how your how your Linux system is going to be, how your Linux system is configured? Possibly not. But if we start thinking about, yes, at some level somebody in the organization will, and you can still specify it in this in the same way. I'll show you that in a moment. But when we started with this, we had application level and application level checks. As I say, that's where Cucumber really came in. That's where BDD started on the application level. As I said right at the very start here, the application is only one part of your whole system. It's possible to undo any amount of application checking, any amount of application rigor very, very easily just by misconfiguring the system. So how do you put the configuration checks in? In the old days, what we used to do was we used to have somebody do the configuration, and then somebody went through and checked the configuration. Nowadays, we really don't want to do that. We want to make sure that if there's a way of configuring the system, then there's something automatically checks it and check that it is actually configured. And I'll show you some I can't show you the complete detail of it, but I'll show you a couple of things that we've been thinking about and working on how to make that work. Similarly with infrastructure, when we're putting infrastructure together, the network, one thing we have been doing one thing I spend a lot of time doing at the moment is trying to configure network security rules so that the various parts of our systems talk to each other, or don't, or are not allowed to talk to each other, and certainly that nobody who's not allowed cannot talk to it. So half of the hardening process that we do on our networks and our infrastructure is closing down ports, and we really want to make sure that when we set some configuration up, that our SQL Server, for example, can only be reached by our application servers. So those are the sorts of infrastructure checks that we are again, we're on a journey here. Those are the infrastructure checks that we're trying to get automated. Similarly, with when we're starting collecting metrics from stuff, when we're starting to do monitoring on things, we want to make sure that actually we are getting the right metrics, make sure that those things are coming through, and are they actually in bounds? Because if they're not, then somebody really needs to know about this. So again, come back to it, right? So another example. So there's the example I showed before. This is a feature for the application part of it. We start looking from an infrastructure part of things. I see no reason we can't do exactly the same thing. What we're doing here is just specifying how we are going to build this, or what we want the end result of building this server to be. So it's got to be hardened, we're using RHEL, and we've got to be able to support so many transactions a day. So what's the scenario? So our scenario here is that we've got a base level virtual machine, which has got Puppet running on it, it's hardened, it does not expose SSH, and it's got a load balance and so on and so forth. It's the sort of thing that you would put in a low-level design, a low-level architecture. The interesting thing about this is that we can, using the tooling that's around nowadays, we can actually run that as an automated test and make sure that that particular system, that particular server meets that criteria. The tooling for that at the moment is not always that accessible. What I'm working to, and I'll try to talk about this at the moment, and what we're working to is actually to try and get it that accessible, that we can write out in English what our specification for the servers are, and go and check that they actually meet that. So that gives us a little bit of independence. We can also run this anytime we want to make sure that it actually does that. So how can we make this work? For the application, we've got Cucumber. For Puppet, where I am currently, we're using Puppet. We use Puppet, a lot of PowerShell, Terraform, and a lot of Bash scripting. But for the application part of it, we're using Cucumber to define the scenarios and to run the scenarios. For the Puppet code, we're using RSpec Puppet to essentially unit test the Puppet code. If you're using Puppet and you're not using RSpec, then I can thoroughly recommend it because it saved us hours and hours of debugging time in Puppet. For PowerShell, we're using Pester, Terraform. We're using server spec, but we're not completely happy with it, and I'll come on to that in a moment. And for testing the whole of infrastructure, we're using Test Kitchen. We, again, not completely happy about that, so this is why we got other tools in development. Don't get me wrong, Server Spec, Test Kitchen, fantastic tools. They're just a little bit slow, and we'd like to speed that up, particularly through the deployment cycle. When we're deploying code and infrastructure, we would like to get that a little bit slicker and a little bit faster. So again, everything we do at the moment is automated deployments. We're currently using Bamboo. Great. It sort of works. It's got some nice features in it. Is it the best? We don't know. It works for us, but we can. I think there's certainly a way to go on in terms of deployment tools, and particularly when you're deploying multiple environments and building blocks. The thing we're trying to move into now is more of the whole coding up the pipelines. So we're trying to get to the state where your build pipeline is also code, and because it's also code, it also needs to be tested. So we will start, when we start putting those things together, we will start making sure that we have ways of testing the pipeline code, that your pipeline is also meets the standards that we expect from build pipelines. We use a lot of per environment configuration files. We want to find a better way of doing that. And one of the big problems with anything that you're doing in either Azure, AWS, or anything in infrastructure is there are a lot of variables. In order just to configure a SQL Server, there's at least half a dozen usernames that we need to configure. So the way that we're getting around this, and we're still not there, but one of the ways around this is to start standardizing this stuff and start using naming conventions. Again, whenever we start doing conventions and things, these are also things that we can start testing. Similarly with the sensible defaults. So our intention is to start codifying up some of the things that we're doing, and to start adding checks in to check compliance with the conventions. We'd also quite like to start actually lifting the whole thing up into specifying levels of compliance. For example, I work in working in an insurance company at the moment. The rule is that all of our servers need to be hardened to CIS level 2 specification, CIS level 2 benchmarks. We have ways of doing that. What we want is we want a way to check that things are hardened to that level. Yeah, sure, Puppet will ensure that it is, as long as Puppet's running and configured correctly. So we want to make sure that what we'd like to do is be able to run those compliance checks, again using behavior-driven development to say, does it meet those specifications? Similarly, again, adding additional testing for the deployment levels. So can we actually, how do we know that deployment is correct? Again, we lift that stuff up. We can write that sort of stuff out. At the end of the deployment, have I got everything that I expected to see? So we're looking to develop. I mean, particularly since we use Terraform for those deployments, we're looking to build out some tools that help that and lift that type of thing up. Okay, on the operate stuff, run, measure, improve. The job's always been here is keep the lights on, do no harm. The old adage used to be, if it isn't broke, don't change it. But nowadays we need to change things more often. We've put in place a number of monitoring tools. There are loads of tools out there. Most of them are quite expensive. I would definitely, having built a few ourselves, we would always go. I think I would always go down the line of it's probably better to buy one. They are expensive, but you need to offset the cost of that one as to how much an outage costs. If you lose a day's worth of business, that probably will. In most places, losing an hour's worth of business will pay for the monitoring tool for a month. Or maybe even a year. One thing we're looking to do, and I have to say I'm not. I know there's a number of people that are well more advanced than we are. We were actually wondering whether there's ways of testing disaster recovery without actually doing it, and whether or not we could automate the testing of the disaster recovery so that we know that that works. I think the question there, and the question is always, if you get a P1 failure on your production system, why would you not go back? Why would you not go back to your DR? Why would you not do that? If you have slightest hesitation, then maybe you're not. Maybe you've got a problem. Some of the questions we keep asking ourselves is, can we test drive this? How do we test drive it? And are we, and what are our tests for the monitoring? How do we know that that stuff is reliable? Some interest, we get all these statistics, we get all these things out, we get all these things that say page hits, page hits per hour or page hits per minute and that type of stuff. Is that stuff actually useful? Are those things actually useful to you? Again, how can we test that those things are actually useful and are correct? I know we can use synthetic data and so on and so forth, but that's really where we're at. And again, is there a way of specifying this in a common way so that we don't have to change the language every time we change the way that we look at things? Every time we change the technology, because that I think is one of the things that we're getting to the stage now where we have so many tools and so many moving parts. It's quite difficult to see things, to context switch from one thing to another. This is why I'm trying to sort of push the BDD language through the various layers and see if we can get more of a holistic view on that. This has been I guess a ramble through the current through my current thinking on where we are with BDD and DevOps. There's some hopefully you've got some thinking points from that one, but I guess the main thing here is just for me is that everything can be code in nowadays. So start thinking about how can we make how can we not repeat stuff? How can we do more with the code that we've got, and how can we and how can we test that the stuff that we're doing is going to work before we do it? That's essentially what BDD is for me. And how can we get the clarity so that when we're talking with stakeholders, that we can go from, I want this to be, we can get into that, I want this to be performant. How can we encode that stuff such that we can prove that it is performant, and then if it ceases to be performant, if it goes out of bounds, we can make it very, very obvious that it's gone out of bounds, and then we can go back around the cycle, we can go back around the plan, build, deploy, operate, to know that it's gone back in bounds. So that was really all I had to say about that. Thank you very much. If you want to learn more about this, then QA Symphony and Magenta will be more than happy to discuss this at great length. Thank you very much, everybody. Guess we're on to the questions part.
All right. We have gotten some great questions in. We've got about 10 minutes left. Let's go ahead and get to the first question. Is the better DevOps, in the better DevOps model, in the better DevOps model, since there was one team, the inter-team handoffs would go away, but the handoffs between individuals would still be there. How do we ensure these handoffs between individuals do not bring inefficiency?
That's a really good question. That's that's a great question. I guess, right, so I think the issue with the handoffs is to me, a lot of it is the handoffs are where the misunderstandings occur. Well, the problem is not really the handoff. The problem is that there is the potential for misunderstanding. Now, if people are working together and in one team, then they build up that common language. You know, everybody has their in jokes. There's always the thing. But you also get to know how people operate and get to know how to say stuff such that they can that you can communicate it in the way that it's most digestible to them. Is that
okay? Hopefully that answers the question. Our next question is, hi, I work on a team that is extremely immature in the plan, build, deploy, operate cycle, and they have very bad habits where one where there is no lack of communication to QA and not providing requirements details. How do you recommend that QA utilizes the discussion points from today's call, and how can we help dev mature in the way they think and work with QA?
Wow, that's a good one. Yeah, that's been half my career. Yeah, it's that I think the main, so there's a couple of things here. One is you need to focus around something that's in common, and this is where the specification comes in. What I didn't show this time, what I showed the last time, was the whole BDD process model, what I call the smiley face diagrams. And I think the one thing, the first thing there is that you need to get everybody around that common view. So and I like the idea of the specifications, and particularly around the specification workshops, of everybody being in that common view there. So you all get the same story, and then we can start. It's coming to this not having that handoff. So everybody's got the same thing. Everybody can then work together and together on that on the scenario. And typically, what I recommend is that if you're working in an agile team, I would recommend that on every story that you pair up developers and testers on every single story. So for each story, make sure that however you do your pairing, that you've got a developer and a tester assigned to the same story. Most things like Jira doesn't allow you to assign 2 people, but find a way to do it.
Okay, great. Just a reminder, we have just a few minutes left, so if you have a last-minute question you want to ask, go ahead and use your control panel. You can send it in. Next question, are there any types of teams or applications where BDDs will certainly not work?
Yes, I think teams that won't talk to each other. I think if you've got a highly political environment, it's going to be hard. It's not going to work anyway. I mean, nothing's going to work. Nothing's going to and solve that. If you're in a highly contractual situation, then and that's the way it's working. I think all of this stuff works on trust. If you don't have that trust, if you can't develop the common language, then I think that's going to make BDD very, very hard. But then, if you can't do that, then I think the system development will be hard anyway. I think you need to. What it will do is it will highlight the problem very quickly.
Okay.
So yeah, I don't. In terms of technologies, in terms of other things, I see no reason why not. Even if you can't do the automation, just by formalizing the specification slightly, that will still give you and opening the communication channel. It will help.
All right, great. Our next question, can I do BDD if I have low levels of automation? And if not, where should I start first?
Right, that's a really good question. That's a really good question. So again, it depends on the technology. It depends on your technologies you're using. I haven't seen anything that we can't start BDD with. Right, so where to start, I think, is to start thinking about example mapping, start thinking about getting specifications down, using a more formal way of writing it. So using the given when thens, getting the specs down that way, and then try putting it in on something where you can do. If you're using Java, then if you're using Java, find a couple of key classes or a couple of the next thing that you're trying to do. Find some classes that you can plug the feature file, or plug it into your feature files and into your if you're using Cucumber, your Cucumber automation, or whatever other automation you're using. But yeah, pick the interesting stuff from and I think one way you can get good quick feedback is where there's a lot of ambiguity and stuff. If you start focusing on the examples, then draw those examples out and then use that as a springboard. Then you start getting a little bit of traction in the team, because people go, oh yeah, remember that one? Yeah, we solved that one that way, and then you can start the ball rolling.
Okay.
But technically, there's not usually a difficult one unless you're using some really, really obscure technology.
Gotcha. Okay. All right. Great. Well, we're about 2 minutes to the top of the hour, so we're going to go ahead and close out the questions now. If we didn't get to your question, I apologize, but please know that that Mike and Kevin will be getting us a copy of the question. So I'm sure they'll be happy to follow up with you offline if necessary. I also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, you will be receiving a link probably this afternoon that will take you to the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always check there for it. Just go under the webinars tab under on demand, and it should be right there waiting for you. While you're on the site, also check around, look at the other webinars that we have, both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Mike Scott, Kevin Dunn, thank you both for taking the time today and giving us such a great presentation. I'm sure the audience got a lot out of it. I know I did. Thanks a lot. Appreciate it.
Yes.
Yeah, thank you.
Great. Well, this is Charlene O'Hanlon, and I am now signing off. Have a great day, everybody.